find the product. The product in this case of two binomials, 2z plus 3 and 6z minus 7. Now what we do to ensure that we distribute each of the first two terms with each of the last two terms, because product means multiply, we are going to multiply the two first terms together. We can symbolize this with this blue arc, F for first. We employ a technique called FOIL. We make sure the first two terms are multiplied together. Then we go to, I'm going to change the light blue for the outer terms. I'm going to connect these with a light blue arc. This is O for outer or outside terms. I'm going to change color again. Then we make sure to multiply the inside terms. I'm underlining the two inside terms in green, connecting them with a green arc. These are the inside terms. We're going to multiply those together. These are each forming what we call partial products. There are 4 partial products that we have to account for. And then let's connect the two last terms. Let's make these red. The two last terms are indicated, connected together with this L. So if we begin multiplying these colors, multiplying these terms together, the first partial product is, I see positive 2z times positive 6z. If I wrote those out, it'd be positive 2z times positive 6z. Then we would find the, I'm just color coding these. Then I would go to the two that are connected with the light blue arc. We would say that positive 2z, there's one end of the arc, the other end of the arc is times negative 7. This is what we would call the outer partial product. Then we're going to multiply the two inner terms together, and that would be this. We're on the inner partial product of positive 3 times positive 6z, and then we are required to multiply the two last terms together. This makes the L in FOIL of positive 3 times negative 7. We take the negative with the 7 for that partial product, and then we are going to go ahead and multiply those together individually. I'm just going to go back to black now. So positive times positive is positive. 2 times 6 is 12. Z to the first times z to the first is z to the second. We use the product rule for exponents on that by adding the exponents. Here on the outer partial product, we have positive times negative makes negative. 2 times 7 is 14, and then there's a z. When we multiply, we're multiplying signs, then numbers, then variables. Here on the inner product, we have positive times positive is positive. 3 times 6 is 18, and a z. Signs, numbers, variables. On the last partial product, we have positive times negative makes negative. 3 times 7 is 21. Then we look for like terms that we might have been produced and try to combine them with addition and subtraction. Here we find a z to the first power and a z to the first power. That makes these two like terms. Z to the first plus z to the first remains z to the first. Now I treat their coefficients like money. I owe somebody $14, but we have 18. I have more than I owe, so the resulting sum is positive. Pay this person back all the 14 we owe. We still have $4 left. This term, a z squared, there's no other term like it, so we just carry it down, 12z squared. This constant is the only one of its kind, so there's nothing to change that. So when we clean it up for all the unnecessary symbols, we have 12z squared plus 4z, we don't need to the first power, minus 21 should be our final product of multiplying these two binomials together. We come up here and carefully select the answer that has all those components, 12z squared plus 4z minus 21. The correct answer appears to be D.